Hi, in this presentation, I will talk about introductions and objectives. So in these introductions, I will explain about the water distribution system, which is essential for any building to ensure proper water delivery for daily use. In schools, an efficient system is especially important to maintain hygiene, sanitation, and smooth operations. To achieve this, the system must meet water demand, minimize losses, and maintain consistent pressure. Key factors like pipe diameter, flow velocity, and fittings can cause head loss, impacting efficiency. By analyzing these factors, we can identify ways to improve the system reliability and sustainability. So now, let's look at the main objective. So first, we need to understand fluid mechanics principles in water distribution. This includes applying theories like Bernoulli's equation and the continuity equation to ensure the system operates efficiently. Next, we focus on identifying key parameters in characteristics such as pipe diameters, water flow rates, pressure levels, and friction losses, which are crucial for optimizing performance. Finally, we calculate flow rates and energy losses. Using the continuity equation, we can determine the flow rate, while the Darcy-Weisbach equation helps us assess energy losses, ensuring the system provides sufficient water for the school's needs. So next, moving on to the next objective is we propose methods to minimize energy losses. This includes choosing appropriate pipe materials, optimizing the pipe layout, and using efficient pumps to reduce friction and pressure losses. Next, we design an efficient piping network by developing a structured layout that ensures even water distribution while minimizing unnecessary bends and restrictions. Then, we evaluate pressure management strategies by analyzing techniques to maintain a consistent and adequate water supply without excessive pressure losses. And lastly, we assess sustainability and water conservation. This involves exploring ways to reduce water waste, implement recycling strategies, and promote long-term sustainable water usage in the school. Thank you.
Alright, so this is my sketch. Shows a plan of the pipe system connected from the main tank to the 6 toilets in the school. These 6 toilets are used by 150%, including students and staff in the school. After the calculation and estimate carried out, we have prepared a tank with a 10,000 capacity of water, with 9,000 water is for daily use and 1,000 left is for emergency use. Following is a view from each side of our sketch. And also include is a sketch of a pump to increase water flow and a valve for maintenance. That's all.
First and foremost, pipes. We use durable steel pipe that can handle high pressure and heavy loads. While they cost more upfront, their strength and low maintenance make them a long-term solution. After that, a pump. A pump keeps the water flowing steadily to all toilets. It's efficient and reliable for maintaining consistent pressure. And then for globe valve. Globe valves are included for precise flow control. They allow adjustment to water flow based on demand, and they are easy to maintain and repair. Last but not least, we use 19° standard elbow to optimize pipeline layout. These fittings are essential for changing the flow direction in tight space such as behind the wall without compromising performance.
Here's are the calculation for this project. Number 1, determine the volume flow rate for a two-story school, a block with 150 people, including students, teachers, and workers. There are 6 toilets. Given water demand 250 liters for each person. Second, after that, by using continuity equation, determine the velocity for both pipe systems. Number 3, then we will use Reynolds number equals to rho v d mu to determine the flow pattern, whether it is laminar or turbulent. Number 4, after that, we calculate roughness using ED. Number 5, then calculate major losses using HF. Number 6, after that, calculate minor losses using formula HM equals to K times V squared per 2G. Number 7, lastly, calculate energy loss by using a formula total loss equals to HF plus HM. Ways to reduce the energy loss that occurs in the system due to friction. Number 1, low resistant valve. Select valve like ball valve or butterfly valve which offer minimal flow restriction compared to globe or gate valve. Number 2, low friction materials. Use materials like PVC for lower internal resistance, especially in non-metallic systems. Number 3, smart monitoring system. Install sensor to track flow, pressure, and energy usage in real time to identify inefficiencies. Number 4, pump sizing. Select pumps that operate near their best efficiency point (BEP) to reduce energy consumption and frictional losses. Number 5, proper pipe sizing. Ensure pipes are correctly sized for the application. Oversized or undersized pipes can increase frictional losses or inefficiency.
In our piping system project, we learn how fluid, like water, behave under the different forces such as pressure and flow speed in pipes. We use the continuity equation to ensure the flow rate stay consistent even when the pipe size change. The Reynolds number help us to understand whether the flow was laminar or turbulent, which affect efficiency. We also studied how pressure drops happen due to friction and other factors using a simple formula like Darcy equation. This helped us to design a system that works efficiently with minimal energy loss. By understanding and applying these principles, we optimized the flow and avoided problems like unstable flow and pressure loss. This insight can improve the design of future systems for industry.